Ever wonder how those really big breakthroughs in AI actually, happen? Today, we're going to dive into something pretty revolutionary. It's changing how we teach AI to reason. And get this, it promises to make advanced AI cheaper and way, way faster to train. We've got this really interesting paper just out, June 2025. It's called Reinforcement Learning Teachers of Test Time Scaling. So our mission today, to unpack this new idea, reinforcement learned teachers, or RLTs, they seem to totally flip the script on how LLMs get their reasoning skills.
Yeah, absolutely. For a while now, this sort of top-tier models for reasoning, things like DeepSeek R1, they've relied on these really complex, super expensive training methods, basically using reinforcement learning where the AI kind of learns to solve problems from scratch. Lots of trial and error.
Okay, learning to solve. Let's unpack that a bit more. What are those traditional ways, and I guess where do they kind of fall short?
Right. So traditionally, you take an LLM and you train it with reinforcement learning on really hard problems. Think complex math, coding, logic puzzles, that kind of stuff. It keeps trying things, and it only gets a reward, a signal, when it hits the correct final answer. That's how DeepSeek R1 got so good, essentially. But there are some big drawbacks. First off, it's incredibly slow and really expensive, needs massive amounts of computing power. Second, it tends to make the models very specialized. They get great at the exact tasks they trained on, but struggle to generalize that skill more broadly. And practically, you can really only do this learning to solve effectively with models that are already huge and expensive. You need a capable base model. Plus, there's this critical misalignment, you could call it. The teacher model, the one generating examples in this setup, it's trained only to solve the problem. Its goal isn't really to produce clear, helpful steps for, say, a student model to learn from. It just wants the right answer, not necessarily the best explanation.
Okay. So it's optimized for getting the answer, not for being a good teacher. That makes sense. Which brings us to the really cool part. This paper introduces something totally new, these RLTs, reinforcement learned teachers. Inspired by human teachers, you said. So how does learning to teach work differently?
Exactly. It's a completely different setup. Instead of trying to solve the problem, the RLT is given the question and the correct answer right at the start. Its job is then to generate a really clear step-by-step explanation connecting the question to the answer, just like a good human teacher would break things down.
Okay, so it knows the destination. It just has to map out the best route.
Precisely. And the way it's trained is also novel. It gets rewarded based on how helpful its explanation is for a separate student model. Helpfulness here is measured technically using log probabilities. Basically, how well does the teacher's explanation help the student predict the correct answer or the next logical step?
So the reward signal is directly tied to student understanding, not just getting the final answer right.
Yes, and that directly tackles the limitations of the old way. It aligns the teacher's goal with actually being helpful for teaching, for distillation. And here's the kicker. Because the RLT gets the answers, even much smaller, more efficient models, ones that could never solve these complex problems on their own, can be trained to be excellent teachers.
Wow, okay. That sounds really efficient. And the results you mentioned. Tiny teachers outperforming massive models. Can you give us some of those numbers again? They sound pretty wild.
They really are quite something. The paper calls it the unreasonable effectiveness of tiny specialized teachers, which sums it up well. So get this. A small RLT model, only 7 billion parameters, which is pretty compact in the LLM world, showed it was a better teacher than something like DeepSeek R1, which has, 671 billion parameters. Huge difference.
Wait, better how? How did they measure that?
They measured it by looking at how well a student model performed after being trained by each teacher. So the 7B RLT teaching a similar 7B student achieved 26.3% performance on a benchmark set. DeepSeek R1 teaching its 7 student only got 18.9%.
Okay, so the small teacher was more effective even with a student its own size.
Right. But even more impressive, that same tiny 7B RLT was used to train a larger student model, one with 32 billion parameters. And that student reached 37.6% performance. That actually beat the score DeepSeek R1 got when it trained a 32B student, which was 34.4%.
That's nuts. A 7B model out-teaching a nearly 700B model, even when training a bigger student.
Exactly. And these aren't trivial tasks either. We're talking benchmarks like the Amy math competition problems, general competition math, and graduate-level question answering stuff like GPQA, and the speed difference. Training that 32B student with the RLT took less than a day on just one compute node, like a single powerful server. Doing that with traditional reinforcement learning, you'd be looking at months on the same hardware. It's a massive efficiency gain.
Less than a day versus months. That's just staggering. Okay, the numbers are compelling. But beyond performance scores, what about the quality of the explanations? Do they actually feel different, like more human-like?
They really do. Qualitatively, the explanations from the RLTs are consistently more focused, they're clearer, more direct. They often include logical steps that the traditional learning to solve models might just skip over because they weren't needed to get their answer. The RLT seems to anticipate what a learner needs. It feels much closer to how a human expert might explain something concisely and clearly.
And then the traditional ones.
The traditional models, like DeepSeek R1 in its raw output, sometimes rely on calling external tools, like a calculator or code interpreter, within their reasoning. Or sometimes you even see weird artifacts, like slightly out-of-place jokes or comments mixed into the steps.
Huh, really? Yokes.
Yeah, it happens sometimes with large models. The RLT explanations are cleaner, more purposeful for teaching. Oh, and another interesting point, this RLT approach isn't necessarily replacing traditional RL entirely, it can actually complement it. You could potentially use RLT explanations as a starting point to make traditional RL even more effective later.
Interesting. So it's not just faster and cheaper. The output is arguably better for learning, too. So stepping back, what does this all mean for the future? If we can train specialized teacher models so efficiently, how does this change how we build advanced AI?
Well, it's potentially a complete rethink, isn't it? It makes applying reinforcement learning feasible in areas where it was maybe too hard or too expensive before. You could see this dramatically changing the economics of training really capable reasoning models. You shift the heavy lifting, the complex part, onto these smaller, cheaper teacher models. It really does kind of flip that traditional scaling idea where you always needed a bigger, more powerful model for everything. Here, small and specialized can be better for the teaching part.
So the bottleneck shifts from raw problem-solving power to effective knowledge distillation.
Exactly. But the paper hints at something even more profound, potentially. What if you had a model that could play both roles, teacher and student?
Teaching it. So
Yeah, imagine a system generating explanations for its own reasoning to help itself understand and improve, learning to teach itself more effectively over time. It touches on this fascinating theoretical concept, sometimes called a Darwin-Gödel machine, a system that can reflect on its own processes and recursively improve itself.
wow. An AI learning to teach itself through self-explanation and recursive learning. That is a really powerful, kind of mind-bending idea to think about. And you mentioned the paper and code are open.
That's right. They've released it publicly, which is great for the community to build on and explore these ideas further.
Okay, so there you have it, a deep dive into reinforcement learning teachers. It feels like a really fundamental shift, moving from just learning to solve to learning to teach. Definitely seems like a game changer for making powerful AI reasoning more efficient, cheaper, and maybe even just better explained.
Absolutely. This idea of a small, specialized teacher being incredibly effective, it really drives home how smart, targeted innovation can unlock huge capabilities. And it reminds you that understanding how knowledge gets transferred, how teaching works, can be just as vital as having the knowledge in the first place, especially
Exactly.
now with so much information out there.
We really hope this exploration gave you some of those aha moments about where AI is heading. It's amazing how a shift in perspective, like focusing on teaching, can potentially change the whole trajectory. Keep thinking, keep questioning, and keep exploring.